Hey guys, Dr. Brown again with Kubo Math coming to you from Tarlac City, Philippines. Hope you've had a great day and you're ready to do more factoring with Algebra 2, Part 2. So let's jump into it. Okay, we have an equation, 3x to the second power minus 6x. How can we pull a term or factors out of that to reduce it? So you'll see that the greatest common multiple of the coefficients, I have a 3 and a 6. Well, 3 will go into 6, so let's pull the 3 out. I have an x here and an x to the second power here, so I can pull one of those x's out. Now the question, what do I multiply by 3x to get 3x to the second power? It's x. What do I multiply times 3x to give me a negative 6x? It's a negative 2. So that would be how the factoring this original equation, what it reduces to. Now naturally, if this were set to 0, for example, that would mean x would have to equal 0. So if 3 times 0 is 0, 0 times this parentheses with anything in there would give me 0. But also, so x would equal 0, but also x minus 2 equals 0, so x equals 2. So 2 minus 2 is 0, 0 times anything is 0. So the two resulting factors are x equals 0, x equal 2. So that's just a quick way of how we could reduce, we could factor, and then solve for the variables in the equation. What about this guy here? Okay, you recall last time we drew a grid around this and we're factoring the ends. Okay, what times x? Well, x times x gives me x to the second power. What about the factors of, let's look at the positive in the beginning, 3 and 1. But I know I have to multiply these together to give me a negative 3. So one of them has to be negative. And then I need to be able to add the results together to get a negative 2. So it tells me I need to put the negative here. Negative 3 times 1 gives me a negative 3. And then negative 3 plus a positive 1 gives me a negative 2. So that's what I need. So let's multiply the diagonals. X times a negative 3 is negative 3x. X times 1 gives me a positive x. Negative 3x plus x is negative 2x, which is what I needed. X times x is x to the second power. Negative 3 times 1 gives me a negative 3. So now my factors end up being x minus 3 times x plus 1. Now if you want to check yourself, you can FOIL this. F-O-I-L, first times first, outer times outer, inner times inner, last times last. So let's do the first. X times x is x to the second power. Outside, 1 times x, so a positive 1 times x is a positive x. Inside, negative 3 times x is negative 3x. Negative 3 times a positive 1 is a negative 3. So now reducing this, x to the second power, negative 3x plus x is negative 2x minus 3. So these factors are exactly what I needed to come up with the original equation. So that's how it factors, how it reduces. Okay, sometimes you see me, instead of doing a FOIL, I will do a FEOIL. So I will do the first, inside, outside, last. I don't know why. Of course, it doesn't change the outcome of the equation, but this is not a word, so don't do it that way. Do the FOIL. All right, let's do number 3 here. X to the second power minus 5x plus 6 is very similar to the problem we just worked. So let's do the grid. X times x is x to the second power But now I have 6 times 1, 3 times 2. And I know I need to multiply them to get a positive 6, so they can either be both positive or both be negative. But I need them to add together to give me a negative 5. Well, if I have a negative 6 and a negative 1, I add those together, it gives me a negative 7. Negative 3 times negative 2 gives me a positive 6, but added together gives me a negative 5. So I know I need to use a negative 3 and a negative 2. So now x times a negative 3, negative 3x, x times a negative 2 is negative 2x. Add those together gives me a negative 5x. X times x is x to the second power. Negative 3 times a negative 2 is a positive 6. So I know, since that came up to be my original equation, that my factors now are x minus 3 and x minus 2. So here and here. Okay, and you could FOIL that to check yourself if you want, or if this were set equal to 0, I would know this one or this one is 0, so 3 minus 3, so x equals 3, 2 minus 2, so x could equal 2. So those would be solutions for that problem. What about this last one? Oh, let me give myself a little room here. 6x to the second power plus 7x minus 5. This one is different in that my coefficient is no longer 1, it's 6. I have a saying though, back when I was in algebra, when I don't know what to do, when in doubt, factor. When in doubt, factor. Okay, if I use that same philosophy here, I don't know what to do with the 6, so I'll factor the 6. Okay. What are the factors of 6? 6 and 1, 3 and 2. I'm just going to try 3x times 2x. That gives me 6x to the second power. Now I have a negative 5, so a negative 5 and a positive 1. I'll just guess those to putting the negative here rather than here. I'll just guess that. But when I do the diagonal, negative 5 times a positive 2 gives me a negative 10x. 1 times 3x gives me 3x. If I add those together, it gives me a negative 7x. I don't need a negative 7x. I need a positive 7x. So I know that I need to move my negative to here. So 5 times 2x is 10x, negative 1 times 3x is negative 3x. That gives me a positive 7x, which I needed. So now 3x times 2x is 6x to the second power. Negative 1 times 5 is negative 5. So the factors then become 3x plus 5, 2x minus 1. And again, if these were set equal to 0, we could solve for x in each one. Sorry, I have a cold. And it's just about to get my voice, so I believe I'll stop there. Hopefully these help. But study, study, study. I can't overemphasize that. Keep working all the problems you can find out on the internet. We didn't have that back in the day. We just had to work what was in textbooks or the library. So there's many resources available today such that you can excel. I would encourage you to do that. Study the algebra rules. Keep those in mind. And together, let's build a better tomorrow. Thank you.